How do you find the feasible region when graphing inequalities? Imagine you are trying to find the area where all your constraints in a problem come together. That's what the feasible region is in graphing inequalities. It's the spot where all the shaded parts overlap. To get there, you start by drawing each inequality separately. First, turn each inequality into an equation to find its boundary line. If the inequality has a less than or greater than sign, draw a dashed line because points on the line are not included. If it has a less than or equal to or greater than or equal to sign, draw a solid line because points on the line are part of the solution. Next, pick a test point that is not on the boundary line, often the point 0, 0 if it's not on the line. Substitute this point into the inequality. If the inequality becomes true, shade the side of the line where the test point is. If it becomes false, shade the opposite side. Repeat this process for all inequalities in the system. Each inequality will have its own shaded region. The feasible region is where all these shaded parts overlap. It's the common area that satisfies every inequality at once. Be sure to include boundary lines if the inequality is less than or equal to or greater than or equal to. If the inequality is strict, like less than or greater than, the boundary line is not part of the feasible region. Sometimes, the feasible region is a polygon, a shape with straight sides, or it can stretch out infinitely in some directions. If no shaded areas overlap, then there is no feasible region, meaning no solution works for all inequalities. This method helps you see the solution set visually, which is especially useful in problems like linear programming, where you want to find the best value within certain limits. Remember to label each boundary line clearly and shade carefully to avoid confusion. Understanding how to find the feasible region makes solving real-world problems involving constraints much easier and clearer.